So it's... thank you. So hello everyone, my name is Anže and I'm going to talk about Django, SQLite and production. And so to start with, at the speaker dinner a few days ago, we were talking how awesome it is at DjangoCon that talks sort of feed off of each other. And that's exactly what I did, because I watched last year's talk by Tom about using SQLite in production, and I got really excited about what Tom was telling us. And Tom was essentially asking us to try out and use SQLite in production and then let us know how it went. And that's exactly what I did. I created a side project and I put SQLite in production. I've been running this side project for the last year. I read most of the documentation in SQLite to better understand how it works, and I even wrote a few blog posts about SQLite and Django, how they work together, all so that I could hopefully answer this question, whether or not we should actually have SQLite in production. And I'm now here to tell you all that the answer to this question is, it depends. Unfortunately, SQLite is quite a peculiar database. It has its strengths and weaknesses, and as an application developer, you do have to be aware of those at least a little bit to make sure that you make a good decision and not create an application that's impossible for you to scale properly. So Tom's talk did an excellent job explaining how SQLite works, so I won't go too much into the details on what he said. I've essentially put his whole talk in a single slide here. So essentially what SQLite is, it's a single file that acts as your database. So that means that you don't really need a DBA like Karen to manage that. It's on your file system. You can access it without connecting to the database server through a username and password. And that, of course, makes it super attractive for us developers, since I can understand how a file on my file system works, so it's a lot easier and less daunting for me to work with that. But it's still ACID compliant. It's in the public domain, so it can be embedded anywhere where you're running your code. It's heavily tested and really, really stable. It's also available anywhere. You can run it on pretty much any machine. It's primarily been used mostly in embedded devices, but as we'll see, it can also work well for use cases where Django comes in, so hosting data for your web application. So just quickly, the side projects that I was working on is called fedidevs.com, and it's essentially an aggregate of different Mastodon accounts so that you can find people to follow that have similar interests as you do. So here we see a list of Django developers, so it's, and it makes it a little bit easier to find friends in the Fediverse. I also built a little feature, so if you want to follow the conversation around conferences, there's an aggregated view that shows all the posts about DjangoCon Europe, so if you want to check that out as well. And Fedidevs essentially started out as a read-only application. I aggregated all the data on my laptop, and I then put it into the SQLite file. And then what I did was I essentially just copied the SQLite file into a Docker image and then just deployed the Docker image. And this is essentially the benefit of the flexibility that SQLite gives you. Since it's a normal file, you can really stick it anywhere and even into places where you probably shouldn't. So I'm not saying that this is what you should do. I'm just saying that if you want something out quickly to gather some feedback, or if you're more of a data science person and just want to share the results of your work, SQLite does give you the option to share this very, very easily with others. And it's still quite fast. I'm not sure if you can see the numbers on this graph, but because this is a benchmark, the numbers don't matter anyway. But we'll see how these numbers change through the different benchmarks that I performed for this talk. Here we can see that SQLite is just slightly faster for read-only operations than Postgres and MySQL, and I believe that is due to the fact that it doesn't have the overhead of connections. It can just access the system, the file system directly. So after I deployed fedidevs in the container, I sort of entered this honeymoon phase with SQLite. Everything was going well. It was just rainbows and butterflies everywhere. Things were fast. I was super happy. But then as people started to use the side project that I built, people also started to ask for new features. And some of these features, of course, required me to support writes as well as just reads. And because the way that I had deployed SQLite, this wasn't just a simple change in the code. I now had to do a few things to make sure that I can actually support writes as well. And most cloud providers, they offer you a way to attach a volume, so some permanent storage to your container image, and then you can put the SQLite file there, and it's going to stay there between your deployments, and that essentially solves this issue for you. Of course, this volume can only be attached to a single instance or a single deployment, which means that some of the benefits that I've had before, where I could just ship that container image pretty much in any data center in the world, now isn't as easily doable. So yeah, I had to remove it from Docker, and that sorted out the deployment issue, but I immediately figured out that there are other problems when you introduce writes into your application with SQLite. And this fact is that writes block your database operations. And by default, if you don't adjust any of the settings, writes not only block other writes to the database, they also block your reads, which means that your throughput is essentially going to plummet if you just start writing to the database while you're reading to it. So in the previous slide, we were doing like, let's say 2,000 requests per second. When I introduced writes to the mix, this number plummeted to 200, 300 requests per second. And this is a 10x decrease in performance and doesn't really sound that appealing anymore. Like, we're sort of seeing some issues in the relationship with me and SQLite at this point. Fortunately, you can at least unblock reads very easily, and you've probably seen this configuration option that enables the write ahead logging. in SQLite. Now, the only reason that this isn't the default already for SQLite itself is because SQLite, like Django, always wants to make sure that all the new features and changes are backwards compatible. So they never changed the default to this new journal mode that was added years after the initial release. But it is a stable way to resolve these issues, at least for your reads. And as we can see for this new benchmark with write-ahead logging enabled, we are back in like around 1,000 requests per second, which makes it still slower than when we were doing the only reads, but it is usually fast enough for certain type of applications. Now, these blocking writes have another issue that you might encounter when you're working with SQLite, and these are databases locked errors. And this sort of confused me quite a bit at first, mostly because, so essentially you get this databases locked error if your write operation can't acquire a lock in the specified amount of time, which is essentially your timeout. So if your write operation isn't able to get the lock in 5 seconds, which is the default, it's going to raise this databases locked error. But what I've noticed is that I kept getting this error on requests that finished in 200 milliseconds or less. So there was something else going on. And when I was debugging this, I even tried setting the timeout to an insanely high number to see if that's going to resolve the issue, but for some reason it hadn't, and I still kept getting these database is locked errors. And yeah, I kept getting these emails, and at this point in time, my relationship with SQLite sort of entered this crisis stage. I was considering maybe migrating the project to Postgres, maybe maybe just try out MySQL. I don't know. It felt like there were issues with how we were doing things with SQLite. I, of course, complained about this on the internet, and as it happens, usually when I'm wrong or confused, the internet sets me straight, and thankfully someone on the internet actually told me to look at how transactions actually work in SQLite, and because that might solve some of the problems that I've been having. So quickly, without going into too much details of ACID isolation levels, I do want to point out that by default, SQLite tries to defer the acquisition of the lock as long as possible. This means that, this is because, as we saw before in the write benchmark, acquiring a lock is expensive and it slows down your database. So SQLite tries to be helpful and tries to do this as late as possible. So in this example here, we started a begin statement. SQLite doesn't essentially do anything at this point. We do our first query. Because this isn't a write query, SQLite still doesn't acquire a lock at this point. And then finally, when we get to this update statement, this is now where SQLite actually needs a lock. So this is where it is going to try to acquire one for you. And if there's no other operation going on at the moment, everything is going to be well. The transaction is going to commit. And at that point, the lock is going to be released. but if there is another write happening at this very moment where we try to access the lock, SQLite won't be able to, of course, attain that lock, and it won't even be able to retry and wait until the timeout passes before raising an exception. And the reason for this is that SQLite has the serializable isolation guarantee, and because at this point we would have to wait for another transaction to continue to finish, that other transaction might change data in the auth user table that we read at the beginning of the transaction, and that could essentially invalidate our assumptions on what we're doing with the update statement, and thus causing potential problems for us. So because of this, there's no retrying in this particular case, and you're going to get the database is locked error in your application when this happens. The solution for this is the begin immediate clause, which basically tells SQLite to acquire the lock at the beginning of the transaction, and then you don't have this problem where you've already read the data before somebody changed it, and that makes this problem go away. But of course, this makes your whole application a little bit slower because the locks are a little bit longer, and that of course impacts performance as well. So we probably all can now see that write-heavy workloads probably aren't the best fit for SQLite because of these limitations, like the serializable isolation mode is not ideal for Django applications, where we're usually used to running in read committed mode, but read committed isn't something that SQLite actually supports. And with writes, it gets even worse, because you might assume that writing to one table in your database doesn't impact writing into other tables in the database, but in SQLite this actually isn't the case. So if you have a big table that is constantly getting writes, like an events table or something like that, it is going to impact writes to the auth users table or any other table in your system. And in this write-only benchmark, we can see that there is an impact to SQLite performance due to all of this. This benchmark was simply inserting a single row into a single table, and even then the performance was much slower, like half the performance of Postgres and MySQL. Although I do have to point out that in this particular benchmark, I was writing about 600 rows per second, which is still quite a lot for most applications. So even though it is slower, measurably slower, it might still be plenty for the use case of your Django application. Now, of course, not for every company, not for every size of load, but for a lot of Django projects, this is probably going to be fast enough. And if you need just a little bit more speed out of your writes, you do have an option to split your database into multiple smaller database files. So like if the events table that I mentioned, an option for you is always to split that into its own database server, database file, and then the writes are going to be unblocked from your other tables. So this is also an option that you can use. Now the main question on everybody's mind right now is probably how to go beyond a single server. So SQLite doesn't have any support for networking or managing connections, which of course makes it a lot simpler to deal with, but when you do have to scale horizontally, things get a little bit more tricky. Now, one solution for this is to use LiteFS, but even then, I would say that for write-heavy applications, it might not be a good fit, since all the writes still have to go to a single database server with, or your single application server that runs your primary database, and you're going to have all the same problems that we had while running on a single server. And of course, as also Karen mentioned, backups are super important when you're running a database in production. And since SQLite is just a single file on your system, you might be tempted to just copy-paste it and make a backup that way. But that is essentially not safe. If you have active connections on the database, and you might end up with a corrupt backup file. So when doing backups, always make sure to use the .backup command inside SQLite, and that's going to make a full backup for you safely. Full backups can sometimes take a long time, especially if your database size has grown quite a lot. So there is also an option of online backups, and that's a tool that you can use called Lightstream that can essentially stream data coming into your SQLite database to some other server or S3 or anywhere else that is safe. So finally, after all of these struggles and learning on how SQLite works, we have finally entered this partnership stage of the relationship, where I now think I understand how SQLite thinks, how it works, and we're now in this healthy relationship. And my goal was to also make sure to help other people trying to be in a relationship with SQLite. I wrote a few blog posts on all of this, and I've also helped make some small contributions to Django itself to make it a little bit easier to deal with. So coming in Django 5.1, there's a new transaction mode option for you to be able to configure immediate transactions for your whole application, and that so that you don't have to deal with databases locked errors the same way that I did. And if you're not able to upgrade to 5.1 immediately, the other option is you have to basically subclass the SQLite backend and then override one of the methods there. We can talk a little bit about this afterwards if you're interested on how to get it to work. And this was actually my first contribution to Django itself, so thank you. So hopefully this is going to be the first of many, so I was really excited to get this change merged into Django itself. The other thing that was added in 5.1 was the init command that you can use to configure certain properties or settings for SQLite so that you can make it a little bit more performant. So these settings are, I basically borrowed them from the Ruby community that is currently going really headfirst into SQLite for pretty much everything. And there's this blog post that I have linked there that goes into a lot of details on what these settings do and why they might be really appropriate for you for the use case of web applications. And this brings us to future improvements. So ideally, I would say that you as the application developer shouldn't really have to know the intricacies of using deferred transactions and all these configuration options. So I do believe that Django should help you, or at least guide you, to get some good defaults out of the box. Now, unfortunately, changing the defaults is difficult because, or we usually don't want to do that because we don't want to break any existing application. But maybe there's other things that we can do. Perhaps the start project template would configure SQLite in a way that's a little bit more appropriate for web application use cases instead of more the embedded world that is the default for SQLite. And I'm planning to start a discussion around this after the 5.1 release and when we see how that goes. And there's always things that we can do to improve the documentation around all of this, so that's also on my mind. Unfortunately, there's a lot more topics about SQLite that I wanted to cover, but just didn't have enough time. So to circle back to the beginning of my talk when I said that I was inspired by a talk from DjangoCon last year, so at least me personally, I would love to see more talks about SQLite, about all of these topics that I have listed here. Like, did you know that you can even have full text search in SQLite? I think that's mind-blowing. So there is definitely a lot more content here, and like the main benefit of using SQLite, like for a lot of use cases, the database is fast enough and reliable enough for us to consider it, and it does simplify the maintenance and the way that we developers interact with the database. So I think it has its place in the Django community, even in production environments. So that's it. If you have questions,